Uh, as you can imagine, since last few months, we have been talking about our curriculum, and we want actually from last 1.5 years, we have been talking curriculum and what kind of revisions does it need, and what are the market challenges, and how can we make our mathematics degree more marketable and more employable, so that a student knowing mathematics can find careers to our understanding wherever he or she likes. So in this presentation, in this talk, I'll be trying to justify your decision of studying mathematics, that studying mathematics was a right decision. And then if you have already studied mathematics, how you can apply that mathematics in decision making in whatever area of life you want to take. So decision, if you made the decision of studying mathematics, that was a useful decision, and we will be guiding you that actually we'll be talking about that actually this was a very good decision you took, and now you have all the areas open in front of you. Okay, so okay, the way I look at mathematics, and I believe I'm talking to people who understand sets. So for me, mathematics is study of sets, relationships between those sets, and those relationships not necessarily have to be only functions. Our graduates sometimes tend to believe that when we are dealing with sets, they are only functions. Actually, we're talking about quite generic thing. And that's another debate, that when we talk about these relations, your modern data science field is all standing on the theory of these relations. And when a student knows mathematics, he actually knows all the terminology. And when we teach him mathematics, we enable him or her with terminology, with examples, explanations, and then connections with those terms. And amazingly, the different subjects we teach them are given titles: real analysis. That means we'll be talking about the real numbers, and we'll try to analyze those real numbers, how those real numbers have a play between them as sets. And then we teach them complex analysis, and then we start talking about the complex number system, the functional analysis, and the spaces, and the vector and tensor analysis. So as I see, a mathematics student takes more analysis courses than in any possible degree. And what he or she should be able to understand, he should be able to understand the patterns, and then he or she should be able to predict. And then the relationships we develop, we tend to quantify them, but can actually, there is a famous video by Steve Jobs. He said, okay, if you want to have everything in your mind and it should stuck to your mind. Now the question for those students who are right at the moment are in MPhil or PhD, the question is, can they connect those dots backwards, so that they are able to analyze what are their expertise and what they have learned. And if they are able to analyze all that, then perhaps we'll be doing useful things with this. And then can we exploit all that learning? This is actually the big question, where all the marketability, employability, innovation, commercialization, that all stands. So this big question, that can we connect the dot backwards, and then can we exploit mathematics we learned? And to connect those dots backward, this is a university is generally meant for knowledge creation. And I am always, when I look at this picture by Bloom, which is this Bloom's taxonomy, we start from remembering facts, then we understand them, and then we must apply them. And then when we apply them, after the applications, we make certain analysis. We solve one problem, then we should be able to evaluate which method is better. And if we know all that, then we should be able to create new stuff. So this Bloom taxonomy, if you go through like in this form, that you from the remember to go, you go to the create level, you will have actually everything working in your favor. So I deliberately included this picture in my presentation. And now we come to this decision making thing. Firstly, as student of mathematics, I started looking at this stuff, and I started believing that whenever you're about to make a decision, that decision is generally like your typical problem solving approach. So when you make a decision, making decisions and solving problems, they go parallel. And actually, if we are able to make decisions and solve problems, life is quite easy, and then you can do whatever you like. So when we make two or more courses of action, you can have more solutions, and you figure out which is the most appropriate from the possible list. And then you can have the intuitive approach or a reason process or a combination of two. If I start thinking like a businessman, over there, two things do matter. When we say intuitive or reason process, over their psychology matters and your arithmetic matters. So over there, your arithmetic is governed by the psychology. So whenever you talk to a businessman, his things do start from psychology stuff. So over there is intuition involved, then there is reason involved, and from there on we start moving ahead. Okay, how we make these decisions? We identify and define the problems. Then once we identify and define the problem, we determine the criteria that will be used to evaluate alternative solutions. So please note that we are already on. So in that Bloom taxonomy, we need to have several things in order to jump to that evaluate stuff. So that means you need to remember certain things, and then you should be able to understand that stuff, then how all that is applied, and then you are analyzing, and then over there, after that, this evaluation stuff happens. So we tend to believe that this comes with experience. And then determine the criteria that will be used to evaluate the alternatives, and then out of those alternatives, you figure out the best one. Evaluate the alternative and choose an alternative. So you can, and this is generally what we do. We have our constraints, and then we follow those constraints, and we ultimately end up having our decisions from the available alternatives. What is this mathematical perspective of decision making? This decision making is like solving a problem or analyzing a situation to search for best optimal solution. In decision making process, firstly, a problem or situation occurs for which you are, and in our mathematical terminology, we say that we need to solve our problems, strict conditions associated to that problems, and we cannot violate those conditions. That is what actually happens in life. You have your constraints and you have your challenges, and you want to attain your challenges despite the fact that those constraints are available. Now, when a mathematician starts making decision, he will do what? He will identify problem, he will identify all constraints associated to problem, and he will formulate models for solution. He will analyze proposed models with constraints associated to that problem, and finally opting for the best solution among the proposed models for the solution of problems. So actually, what we call the problem solving in life, decision making is the same stuff. Now, when we say decision making, teach this decision course under different names. Just recall your operations research course. You have an objective function and you have certain constraints associated. And over there, this course of decision making is called operations research. Then we, at all times, we start calling it optimization theory. Over there, we involve all that linear algebra, we involve that calculus of several variables, and then we are looking for the maxima minima stuff. Then the quantitative management, the data stuff. If you look at the management sciences degree courses, over there you will always find operations research course, you will always find optimization theory course, and if you are thinking like a businessman, you will always come up with data. And in order to figure out useful information out of that data, we need these analytics course. And the purpose is very simple. The purpose is to apply quantitative methods to help people, business, governments, public services, military, event organizers, and financial investors finding out ways in which they do better. Now, before jumping into this business and mathematics, and which I name as business analytics stuff, the challenge generally our mathematics students have is that we tend to solve all those problems, and we somehow forget the intuition why we started all that debate. So if we develop a some reason, we must implement all that theory. And if we start implementing that theory, then immediately we will be able to figure out that a mathematical theory can be applied in so many different directions. When that theory is developed, maybe that theory is developed for one reason. But when you are able to figure out those solutions can be applied in many, many diverse directions. Just an example, in your OR course or in your optimization course, your linear programming problems or your non-linear programming problems, you find many different things with them. For example, you have a diet problem, you have your scheduling problem, you have your transportation problems, and you can think about purchasing something under certain constraints. Or you are a businessman and you want to maximize your profit, but you must have certain constraints which you certainly need some spending to generate that profit. So all those problems over there, we look at those problems, we solve the theoretical stuff, we don't generally jump into the applications. When we target those applications, those simple applications, and we use terminology from mathematics and let's suppose terminology from business, and then such subjects emerging, the so-called business analytics. So whenever we are in business is always surrounded with decision-making challenges, which we need to be dealt in a proper fashion so that they don't arise again and again. Okay, so mathematics does what? Mathematics not only those different solutions to those problems, and then if we solve a business problem, we have several techniques available, and then we can say, okay, that technique is preferable over the others. And then learning and using business mathematics enables a person to think out of the box. It can sharpen one's thinking and helps in precisely formulating and structuring relationship. So generally people tend to believe that actually mathematics is extension of common sense. So we always do logical things. We always deal in logical stuff. So, and logic is needed in every field of life. So mathematicians are supposed to be sharp in their thinking patterns. So more precisely, business analytics, actually we have included this course in our curriculum, and we're quite excited about it because this will enable the students to understand terminology from business, and he or she already knows associated mathematics. So when we'll merge these two fields, we'll end up having a subject which is business analytics. And one more thing, this subject needs computer wit. So if you want to understand this business analytics stuff, you must have good command over computer. That means you are able to program. So we need computer science stuff, then need the business stuff, then we need the statistics stuff, and all these things, they can't work without knowing mathematical terminology associated with it. Today, the modern subjects, they are not based on one particular, for example, if you know mathematics, okay, you can extend your mathematics as an application to business analytics. And after you know this business analytics, you can find amazing careers. And this business analytics is used by the commercial enterprises to record and manage business operations. And it enables to identify relationships between variables. So as a business, look at those tables, and over there, when you look at tables, those tables have column labels and several column labels. Let's suppose there are 10 columns and labels. if you don't know mathematics associated with it, as a businessman, you're not able to figure out anything out of it. So you must have the technique which can identify the relationships between the columns of data. Then commercial use mathematics in accounting. Then the inventory management. When I say inventory management, you are a businessman and you want to have stocks of certain things, and then there are expiry issues, and then the place issues, the storage issues. So inventory management is a serious subject in business management, and this inventory management, this really works well with mathematics. Then the marketing, sales, forecasting. You want to forecast something, you want to predict something, the behaviors. You can't predict any behaviors without mathematics. And then this financial analysis. You want to predict markets, you want to give predictions, and you want to have those different instruments associated to finance, you want to deal them. This financial analysis, you must have a good grip on mathematics, and then you must be familiar with the terminology from finance, and then you can find amazing careers. And incidentally, one of our panelists, he started his career as an engineer and he ended up being financial analyst. So you need to figure out that what are the skills needed for this financial analysis. I am not an expert, so my approach might have few questions. Then this mathematics is typically used in business and commerce, including elementary arithmetic that everyone knows. Then the elementary algebra, the statistics and the probability stuff. And then for some management problem, more advanced mathematics, that is calculus, matrix, algebra. This is known to everybody. So this is just stating the obvious. But the careers which you can figure out are where you can know business, where you know mathematics, and with the help, if you know terminology from business, mathematics, business analytics, that I know business analytics, and then you can find amazing careers. Okay, game theory, the science of competition. This is branch of applied mathematics. We added it in our curriculum, and wherever you will find a competition of any sort, be it economic competition, you want to start a new industry and there is always a competition and you want to analyze the competition, you need game theory. You are in a political debate, you are in a political scenario, your political parties are having some rivalries against each other. One party will come with one strategy, other party will come with another strategy. If you can think about your strategy and your opponent's strategy, the subject which emerges is game theory. And whenever you make decisions, you already know that your decisions will have impacts on others and they will obviously react to your decisions. So this subject will enable you to understand the science of competition. In any existing economics degree, the degree is income knowing the game theory stuff. We have added it into our curriculum, and when we have those solutions, we will always look for the optimal solutions, and a solution to game describes the optimal solution of the players who may be similar, opposed, mixed interest, and the outcomes that may result from these decisions. Okay, one thing, when you study this game theory, there are cooperative games and non-cooperative games. Then there are finite games and infinite games. For example, there are certain rivalries which have no limits. They are infinite games, and that means you have to live with that battle. Maybe the rival countries, that's an infinite game, and the game will go on. And then you hear about certain organizations, that those organizations, certain countries are members of those organizations, and then there is a cooperation organization, cooperation deed, and then cooperation deed means that there will be a game played which is a cooperative game where each partner will be taking care of the interest of the other collaborator. So this game theory will enable you to understand various scenarios. The conflicting scenarios are the parallel scenarios, are the scenarios where you have the common interests. And obviously, whenever you jump into business, game theory is always there. Whenever you are in business, there is always competition. And the competition may involve a product-based decisions. You launched a new product and your product may backfire. Your money may be lost in that because the existing product can be better than your product. the marketing strategy. So whenever you come up with marketing strategy, you need to know the competition, and this game theory terminology enables you over there. Then this game theory, business people can understand if the first mover advantage is there or not. So this game theory gives you the advantage if you take the first move. For example, as you know, in every game there is this theory of toss. Whenever you make a toss, you tend to take the advantage, the beginner's advantage, the first move advantage. So this game theory and the advantage you will have as the first mover. And then this concept of game theory is always interesting when you're jumping into a new market, or you tend to figure out, okay, maybe I will not be able to survive in this market anymore. For example, this mobile industry, it faced a revolution when this touch mobile came into play. So many old products, they had to exit from the market because they could not compete well. So this game theory enables you to decide if you can survive in the market or you must exit. Okay, from a mathematical perspective, if you know calculus, you know linear algebra, rather advanced linear algebra and advanced calculus, you must believe that you can go through any book of your liking. Actuarial science is one example, and when you talk about actuarial sciences, you can, as a student, you need to understand that commerce, business, banking, and finance, they're different fields. Economics, they are different fields. So all these different fields, they need their own mathematical theories. So this actuarial science and mathematics, this actuarial science is the discipline that applied mathematical and statistical methods to that. This discipline applies mathematical statistical methods to assess risk in insurance, finance, and other industries and professions. So those actuaries, people who are such experts, apply mathematical and statistical theories to solve these real-time problems, and these actuaries assemble and analyze data to estimate the probability and likely cost of an event, such as death. For example, whenever you face with some freelancer from this insurance policy, he will always tell you that I'll give you a plan, and that plan may vary with your age and certain things you pick in their list. So they will actually, based on certain theories, they will always come up with the different, that okay, you will have to pay this much cost for this particular benefit. And if you are, for example, 35 years of age and you purchase an insurance policy worth, let's suppose, 50 lakh, you may have to pay a different premium as compared to if you take the same policy at 45 years of age. So these actuaries, they propose their solutions in such scenarios. So life insurance is one of the largest practice areas for these actuaries, and this is what I've already said. And the first and foremost work that actuaries do is setting up premiums for various life insurance products. And as mathematicians, young people can find careers in these fields. And as I already said, advanced calculus, advanced linear algebra, computers, in a basic introduction of computer science, the few computer courses can enable them to jump over there. Then operations research. Well, you already know a lot about this operations research and the optimization theory. I already spoke about this. This is, we call it the mathematical decision making. You have certain constraints, certain target functions, and operations research and decision making go parallel. Then this operations research and management and control. Operations research is always there in business administration degrees, and because over there they need to manage their operations under certain constraints. So over there, all the decision making is made under using this terminology from operations research. Then the optimization theory. Optimization theory includes the nonlinear programming and linear programming. You always need to maximize or minimize the objective function under certain constraints. So this optimization theory course, whenever you want to take a decision, you need to optimize. That means you want to minimize your expense and you want to maximize your profits. And then forecasting. You have a data and you continue to look at that data. And out of that data, you want to predict what is going to happen. And this data is based on, you collect that data on different times. For example, maybe this COVID prediction, you can look at the data and the time of the year where those curves do happen, and you can predict or forecast the trends. And this is another problem from the decision making, and none other than mathematicians can handle better. In the quantitative analysis, this quantitative analysis, we also called financial mathematics. This quantitative analysis is a technique that uses mathematics and statistic modeling, measurements to reach minimum, and research and analyze past, current, and future events. So these analyses present a given reality in terms of numerical values. So generally, people will come up with some statement and they will ask you to model a problem for them. So these analysts do the job, and then quantitative analysis is applied to the measurement, performance evaluation, valuation of a financial instrument, and predicting real world events such as changes in countries' GDP. And these people are called quants. And the quantitative analysis in financial market, in financial services, these experts have their careers, and this QA is used to analyze investment opportunities, such as when to purchase or sell securities. A quant implements statistical math in order to understand and forecast the financial market behaviors. And then they have expertise, experience in programming and trading and other skills to be genuinely excellent at work. A typical problem for quant would be to develop a model for pricing, hedging. Hedging means that you will provide a shelter to the losses, and managing a complex derivative product. So when we say that, and these derivative products, these are various financial instruments, what we call them. And before I close, I'll be jumping into a bit of data analysis. So suppose you have an information table with you, a simple table, and you look at that table in form of matrix, or maybe as a table, and you figure out that actually there are, let's suppose that table has 100 entries, and you figure out that those 100 entries are further, let's suppose 50 entries look exactly alike. So as mathematician, if you imagine it as like a matrix, you will say that I will not write those 50 entries, I will write actually only one of them, and the remaining 49 will be named as redundant and will be removed. And from the remaining 50, you figure out that actually there are 5 other groups. So a layman has 100 entries, and a mathematician ends up having only 6 to 7 those rows. And then if you have those rows in front of you, then you will be able to better look at that data, comment at that data, and you will be able to make better decisions. So I summarize whatever I said. So mathematicians, if they have already taken this course, they can figure out, they should be better decision makers. If you took optimization theory course, operations research course, you are already, you can theory. This is competition, deals with competition scenario of market and politics. The business want to make business decisions. So please note, when I speak the word intelligence, that means intelligence is the ability to learn from experience and then adjust accordingly. So this business intelligence means that you are a businessman, you look at the previous behaviors, you figure out the conclusions, and then you make those business decisions. I already spoke actuarial mathematics and quantitative analysis and financial mathematics, and then at the end I spoke about data analysis. So if you are a mathematician, there is huge amount of careers for you. I did not talk about teaching intentionally, because that is what everybody believes, that mathematicians find careers only in teaching. So I told you these many careers, and teaching is another one. So you are encouraged to take mathematics courses for your for any field you want to take, and the era we are already in, you can't avoid this mathematics, you can't avoid this this information technology thing, and obviously you can't avoid the language thing, which is English. Thank you very much.
Thank you so much, Dr. Imran. Maybe we take a couple of questions. The first question we have is from Wahid Baksh. And he is asking, the purpose of struggle of students remains to obtain some marks to qualify their classes. So how can they enhance their creative ability?
It depends upon the approach. I can't think of a student who knows mathematics and scores poor. So if student is interested in mathematics, there are 45 lectures. And if you want to prepare for exam and you already know the course content, you can prepare for the exam when exam appears. And if you know the subject, you're already an expert. And I can't think of an expert who can't respond to exam questions. So if this is actually about the dominant thought. If you are trying to learn mathematics, you will surely get very good grades. But if you are constantly after exams, then maybe you will forget everything else.
Okay, and the other question is maybe about our latest panel's discussion. Let me take this opportunity to ask this question from one of the attendees, Wahid Baksh. He asks how to change the strict mindset of children and adults towards the easiness of mathematics.
Should I respond?
Yes, sir, please.
Actually, okay, mathematics is extension of common sense. So if we start teaching it better, there is nothing hard. You are, and as was title of my talk, you take decisions daily, and your decisions are driven by common sense. If you start somehow, when a mathematics book is written, we generally tend to introduce terminology to the student. Then sometimes we get lost in the terminology and in the explanation of terminology, that we generally don't really that terminology learned. So that, in my opinion, that is where problem happens. So for me, if you about mathematics as something which is rational, which is associated with common sense, and all that terminology to support your decisions and understanding, maybe then the subject will become really easy. And if you somehow get lost in terminology, then maybe teaching will be the only profession left, and such teachers will be labeled as bad teachers.
Okay, so there are some more questions. Maybe the speaker can answer them in the question and answer chat mode. And we would like to move to our next talk. So thank you so much, sir. It's been a very nice and informative talk.
Make one comment openly. I would like to make one comment only. Actually, the question which is that institutions are maybe not prepared. So when we were designing this curriculum, we did not import this curriculum from anywhere else. This curriculum was prepared by our own faculty members. So the purpose of this activity was, and actually all those faculty members are somehow engaged in this activity. We at CASPAM have the relevant experts, and we have the relevant, and we are confident that we will be able to teach these modern courses in the modern manner. So maybe 3, 4, 5 years, this debate will evaporate that we don't have experts to develop these skills. We hope that we will have experts, and we are in the era of self-learning. So there will be some effort left for the young people as well. I think I should stop for the next speaker. Thank you very much.
Thank you so much, sir.